And with this, welcome to the review meeting for the 1.128 release. Today we have a lot of topics, a lot of short ones. We will start with Johannes and the machine image capabilities API from GAP 33. Next one is Axel with the dual stack migration of the kube-dns service. And then we have Sebastian with another networking topic, the custom CoreDNS configuration support for node-local-dns. Then we have two dashboard topics, some general updates from Peter and Mark with the project title support. Then we have Ismail with the new guideline document for developers when writing validation code. And finally, Vladimir with the dedicated groups for the shoot cluster access. Okay, then Johannes, please get started with the first topic.
Yeah, thanks. So then let's get started. So I will present a new feature for the cloud profile, the machine capabilities, and let's jump right into some motivation. So currently, we don't have a good mechanism of matching specific machine types that have specific requirements on machine images other than the architecture. So for example, in the GAP, we have the example here on the Azure cloud provider that they have specific machine types that only support a specific type of hypervisor, either generation 1, generation 2, or even both. And currently, users that create shoots, they select a machine type. They can choose the right architecture, and also the images get filtered by the architecture. And then he has to choose an image. And this looks like this. He can choose some version or some version with a suffix. And this is the way how we currently manage to get different type of flavors of one machine image versions in a cloud profile. But this is error prone, as the user now has to know what image will boot with that machine type, because if he chooses the wrong one, the image will not even, the machine will not even boot and will not join the cluster. And even worse, this can even happen in some maintenance operation when a new version of a machine image is released and we chose the version with a suffix, it will be upgraded to the version without a suffix and the cluster will break during maintenance operation. So now we introduce the machine capabilities to model these kinds of dependencies in the cloud profile. And now I want to share with you how this could look and how a transition would look like from a cloud profile without capabilities to a cloud profile with capabilities. Here I have an example cloud profile that has just one version for the time being. And the version is published with the architecture of AMD. And we have one machine type also with the architecture of AMD. And if we scroll down here, we can see in the provider config, we have this mapping now here. We have the image local and the version 1, the image reference to the specific point where the image is stored, and then also the architecture mapped with a mapping from this architecture to the version up here. Okay, now let's say we want to transition exactly this cloud profile to use the new machine capabilities. This will look like that. We have a new top-level attribute on the spec, which is called machine capabilities. And this consists of a list of capabilities with their respective values. So for now, as we are just transitioning an existing cloud profile that only uses one architecture, we would have a key of architecture, and only possible values are AMD 64. So for our version, this would mean, remember, our goal is to have from one version of a machine image different flavors that have drivers or capabilities for different machines. So we have now here a field called capability flavors on the versions that has an array of different flavors we can have. And currently this would only be one element, also the architecture of AMD. For the machine types, the same. We also added a map, which is the capabilities and the architecture of ARM. And here, same as above, we have a version with the capabilities flavors and one element that contains the image reference with its corresponding capabilities. And as currently the capability architecture fulfills all the needs that we have defined in the definition, we could even remove it. And as we have now no capabilities in the map, we could also remove the capabilities field. Same for the machine types, and even same for the capability flavors up here. So this would mean a simple cloud profile that only uses one architecture. The change would be pretty minimal. Now let's be a bit more for our example. And let's say we also have these hypervisor situation that different generation of hypervisors are used by our machines. So first of all, we would define the capability. Let's say we call it hypervisor. We can call it whatever we want inside our cloud profile, because the capabilities are only contained within a cloud profile. So different cloud provider, different cloud profiles can have totally different definitions here. We have one generation 2 hypervisor, one generation 1 hypervisor, and we also added a new image version that now has in the capability flavors 2 elements. One that is the architecture of AMD with a generation 2 hypervisor support, and one that is AMD with a generation 1 hypervisor support. And if we go down to our existing versions, here now not all capabilities are provided, so we have to add them also. And here we only support AMD with hypervisor generation 1. Also now we added a new machine type that requires AMD with hypervisor generation 2 and made sure that every machine type has the required capabilities. Also in the provider config, we added the new version, and here in the capability flavors, we have now 2 flavor entries, one for Gen 2, one for Gen 1. Okay, now let's get a little bit more crazy and more realistic and say we also have ARM architectures and bare metal machines. We have now a new version that supports all these different entries, like bare metal ARM, bare metal AMD, generation 2 for ARM, and we even managed to get AMD running in one version that supports both hypervisors at the same time. And last but not least, let's say we want to also phase out the first 2 hypervisor generations. This we could also now do with adding a new version, let's say version 3 now, and this only supports now bare metal for AMD and for ARM. And with this, we could safely then transition out the machines. We could say, okay, version 2 is now deprecated, and we could safely assume that hypervisor with Gen 1 and Gen 2 are not upgraded automatically to version 3 because this is not supported. This does not support the capabilities, and time after time we could then delete the older versions. Okay, now for a quick example how this would now look like if we create a shoot. I have this exact cloud profile, and let's take a look at the different machine types that we have. We have now some bare metal ARM and AMD machines. We have some ARM generation 2 hypervisor machines and all these different combinations that we have. And we will create a shoot with all these different machines. And let's have a look how this will look like. And let's, for time constraints, look directly at the workers. So we created a shoot with these workers, and now let's see what it assigned to the different machines. So we can see for the ARM bare metal and AMD bare metal and ARM bare metal, it assigned correctly the newest version, the version 3. And for example, for the AMD generation 1 and generation 2, we fixed it to the version 2, so it took the version 2. And for ARM generation 2, it took the newest version that supports hypervisor generation 2, which is the 2.1. And these information are also stored in the respective places, for example, in the provider status of the worker, where we, that was the wrong one, where we also store these images in case we delete the cloud profile before all workers with these machines are deleted. We also store it down here. We can see in the worker status we have machine images, and now we can see we have the version 3 2 times. One with bare metal AMD, one with bare metal ARM. And yeah, this is how we can now model these dependencies between machine image version flavors and the machine types. And yeah, this is currently only implemented in the provider local, and other providers will soon follow, but we are very open for feedback to see if we can improve here. And with that, any questions? And back to Raphael.
Thanks. We would have time for 1 or 2 questions if you want.
Well presented. Thanks for elaborating on the motivation. That made it clear to me. Thanks.
Okay, cool. Thanks, Johannes. Then over to Axel for another improvement in the dual stack migration area. Let's go ahead.
Yeah, hi. This is about an additional, what? Wait. Yeah, this PR is, in this PR we added an additional step in the migration process. Before this change, the migration was actually pretty much complete in a way that we have dual stack ingress and egress. So new pods got IPv4 and IPv6 addresses. It was possible to create dual stack services. So actually, we thought we finished with the migration, but there was rather an edge case that we were maybe missing. We created the service kube-dns as a dual stack service, but the CoreDNS pods are not yet restarted, so they don't have IPv6 addresses. And so there's no endpoint slice for IPv6. And if a pod tries to query a DNS entry via the IPv6 address of the service, that would fail. So we thought that just restarting the CoreDNS pods would solve that issue, but that was actually not the case. The IPv6 addresses, the new IPv6 addresses of the pods are not automatically picked up for a new endpoint slice, and it's necessary to recreate the service actually. So the order is important here. First, we need to restart the CoreDNS pods to get IPv6 addresses, and then we can configure the kube-dns service to dual stack. So as an example, I have here created a shoot already. Here are the constraints. We are in this new, I already migrated the shoot until this two last steps for the DNS migration. Yeah, we have the kube-dns service on this side. It's currently a single stack service and only has an IPv4 cluster IP. And looking at the pods, the CoreDNS pods have only an IPv4 pod address. We see that the node already has IPv6. If we restart this CoreDNS pod now, it will get an IPv6 address. So just reconcile the shoot to trigger the last steps. CoreDNS pods should now be recreated. Should only take a few more seconds. We recreate the pods by annotating the deployment with an hash or a string indicating that the IP families have changed and the pods are recreated. Now, reconciliation is already through. So, but the restart of the pods is more or less asynchronous. Takes a little bit more time. Yeah, it's rolled out. Just wait it for finishing, and then we can trigger next reconcile to also reconfigure the service. It's slow. Maybe I can just speed it up by deleting this old one here. I'm not faking here. It's just to speed it up a bit. So the 2 old pods are terminating. Just wait until they're gone. So during the reconciliation, we check if there's a pod with only IPv4 addresses. If they are gone, then the service will be recreated. Or we can look at the endpoint slices. Right now, there's just one for the IPv4. Now we get the IPv6. We got IPv6 endpoint slice, and let's look at the service. Now it's a dual stack service with both IP families and a cluster IP for IPv6. If we now query via this address from a different pod, we will get an answer, so that will work. Just look at the constraints in a shoot. So we don't have any migration constraint here. So now migration is finished. Yeah, that's all from my side for now. Any questions?
Apparently not. Then thanks, Axel, and over to Sebastian.
Okay, then let me share my screen. I hope you can see it. So what that change is about, which I want to present to you. So at some point in time, we would like to have for all clusters which we have node-local-dns as a de facto standard. And in order to do that, so we have presented in the past a change which makes it possible, instead of rolling old node-local-dns, so if you switch it on or off, to just run a cleanup job, and then node-local-dns gets enabled. So the necessity to roll the nodes is not longer valid. And another change which we have to do is we want to keep the same behavior for our stakeholders once we enable node-local-dns, then if they only run CoreDNS. And with CoreDNS, you can also specify a custom config map. This is what this change is about. In our Gardener section in documentation, we have some documentation for that. And basically, in the CoreDNS custom config map, you can either specify a separate server block. So if you want to specify your own behavior, or override the current server with a core-fi override. And that is also what a lot of our stakeholders are doing. And when we use node-local-dns, node-local-dns works as a caching client, and it looks for the DNS requests in its cache, and if they are not there, they get forwarded to CoreDNS. But if it's an upstream request, for example, to some infrastructure DNS server, it basically skips the CoreDNS and sets the request directly to the DNS server. This would break the behavior. So if a stakeholder, for example, has a custom CoreDNS config and has, for example, nginx.com, and he wants to resolve it to some cluster internal DNS entry, he can do that. And with a node-local-dns, this would no longer work, as the request would directly send to the upstream DNS server. And in the past, we had to specify that flag disable forward to upstream DNS, so that we would skip and send all requests from node-local-dns to CoreDNS and not to the upstream DNS server. And with that change, we also mount the config map of the custom CoreDNS config into node-local-dns. We can look at that. So I have a cluster which contains that change. And if we now look at the config map of node-local-dns, we see now that we also have an import part for the custom override, if you want to override, as I said, the current configuration, and also we import the server configuration. And let me just show you the CoreDNS config map, the custom one, CoreDNS custom show YAML. So you see that I've added here a core file override. For example, I rewrite the request, the domain name nginx.com to a cluster internal IP. So I've added also to my cluster an nginx, exposed it via a cluster internal service, and added that endpoint. And now I have on my left side an Ubuntu pod, and I just want to curl nginx.com. And now we should see the response from our internal nginx, which you can see here. So you see that now also this works for node-local-dns, a custom CoreDNS config map, and we would no longer have to add this flag. So that's what this PR is about. Okay, that basically was it from my side. Any questions?
All right. Thanks, Sebastian. Then next one is Peter with some updates for the Gardener dashboard. We can't hear you, Peter. I think you're still muted.
Oh, yeah, no, sorry.
Yeah. Okay.
Okay, so today I want to demo two enhancements that we did for the Gardener dashboard. The first is regarding real-time updates for seeds. So previously, when you load the dashboard, we fetch the seeds once and never receive updates for them. And that's why we couldn't show the conditions on the UI, because it wouldn't make any sense. But now, as we have the real-time updates for the seeds, we can now also show, for example, the conditions for a seed that we show in the seed readiness column for the respective seed of the shoot cluster. And the seed column we display now right next to this seed readiness column. And so to demonstrate that something is actually happening, I'm using a local development tool to simulate stuff. In this case, I want to toggle the health of seed clusters. And error rate I specify as 30% with an interval of 1 second. I started, and now after some seconds, we should date. Yeah, so this is basically a basis for introducing, for example, a new page only for the seeds, where we display the seeds and yeah, information about the seed, so dedicated seed page. This page, and yeah, the next one is an enhancement for the custom fields feature, which I demoed in one of the last review meetings with the, if you didn't hear about that yet, with the custom fields, you can define fields that should be shown in the dashboard, either in the shoot list or in the on the shoot details page. So here I defined two custom fields, And I also defined where the dashboard can find the value for this custom field. Here I take it from the annotation. So I have a contact defined in the annotations. In this case, I use default status label that Gardener sets. And it's then shown here on the good list. And here's the contact. And so what this pull request is about is we added an icon picker with custom fields. Previously, you would go to some material design icon page and search for the icon you are looking for and then enter it here in an input field without much help. And now you can have basically the whole list you can scroll through, or if you know roughly what you want to see, you can type it in, filter it. And let's choose this one here. And yeah, that's it. And it's shown then also on the details page here. Yes, I guess that's it from the Gardener dashboard side. And next topic is also for the Gardener dashboard, which Mark will present, I guess.
Peter. All right, I'll immediately continue. Hello, everybody. I presented this topic a while ago after the last Gardener hackathon. This was still in development. It's about the project title features. Now this is finished and merged into the dashboard and available, and it changed a bit since, so just giving you a quick update. To give you the motivation, I'm using a local Gardener deployment here with the dashboard running locally as well. If I'm creating a project, maybe you're aware of this, there's a length limitation, which is indirectly also due to DNS name length regulation. So if I have this name that I'd like to use for my project, I can easily run into a situation where I can't use what I want to use. I can do the typical thing of just removing the vowels from the name and then have it that way, but more and more projects, this can get quite difficult to understand what projects are available and which project I am in. So with this project title feature that you see in the dashboard, you can add any human readable title to it that you want. So I can do my crazy botany for this project. And if I want to, I could even give it a little emoji in here. As you can see, this then translates into this project picker showing this title underneath in the subline. So you still see the technical name, but you also see the title. You get this new tooltip that also shows you owner or who created this project. And of course, the title is picked up in things like the title bar for the web page, but also in other dialogues, such as if we want to remove this project again, we will also be able to see that it has a title set. Aside from that, of course, if you are in the overview for all the Kubernetes clusters here, maybe as an operator can do, you could imagine a situation where you have randomly generated project names, such as these. So again, going in here, we could give any title to this one. Let's say this is our development project. And then going into the overview again, this becomes a bit easier to deal with. We still have the technical identifier, but we also see that this is now a project meant for development, even though it holds a production cluster. Of course, the search also works. So if I'm searching for development, that picks up the project title. And the same is true in the project picker on the left-hand side here. Finally, just to show you this one, if we enter some malicious data, you can do that, but it's not evaluated as JavaScript in this case. So you're still safe here. Also to show you on the kubectl end of things, if I query all the projects, let's get this XSS project that I just showed before. Currently, this title is represented as an dashboard-specific annotation that you can see up here. We're also thinking about perhaps in the future making this a proper field of the project resource, since then we could also add the same validation as just 2 weeks ago has been introduced with this PR against other fields of the project resource. But just for now, this is an annotation on your project, which is invisible in the dashboard.
that's it. Any questions? Otherwise, back to you, Raphael.
Awesome. Thanks, Peter and Mark. And then we have Ismail with a new document for developers about guidelines for validation.
Hi, folks. Let me share. Okay, I will present this PR, the developer guidelines for validation. As you may know, we already have 2 developer or 3 developer guidelines, which I find quite useful. One of them was for testing, the different testing strategies we have. One of them was for logging, how to deal with logging in our components. The other that I can recall is for Kubernetes clients. With this PR, we add yet another developer guideline, and it is for validation. The motivation to add these guidelines was to describe how the different validation approaches that we have in our code base, and describe when to use which of the validation approaches. There was feedback also that it's not really easy to locate validation codes, so this is also covered with this guide. The best practices, we now have best practices that document all the tribal knowledge that was present so far, which was not really documented in one place. And we also have now with this guide common utility packages and functions that developers can use when writing their validation code. Actually, we have 2 validation guidelines. One of them is for Gartner specific, and one of them is for extensions. Let me start with the Gartner guidelines. First, we have the motivation for validation, so why we have to write validation code. I won't stop on that section. I think it's clear for most of us. The next section was for validation itself in Gartner. You know that in Gartner we make use of all the existing extensibility approaches of Kubernetes, extension or aggregated API server, and customer source definitions. So the guide covers the validation approaches for both of them. If we start with the extension or aggregated API servers, for them, a validation code can be added in the storage layer or in API server admission plugins. The guide describes how the validation in the storage layer looks like, when to prefer a validation in the storage layer, and also some best practices when writing validation code there in the storage layer. The same is also done for the API server admission plugins, when to choose them and what to pay attention for when writing validation API server admission plugin. Next, we have customer source definitions and component configurations. If you are offering Gartner directly to end users, then APIs like customer source definitions or APIs exposed via CRDs and component configurations, they are internal ones, but they are still subject to validation, so we have to write validation code for them. We cover the API groups exposed and used by Gartner and where the validation happens and in which packages. The same is done also for component configurations. Next, we have the utility functions that extension developer or developers, maintainers can use. I split the section here into two parts, utility functions and packages from Kubernetes and ones from Garner. Yeah, here I try to cover for each and every supported data type, so to say. For example, how to validate names, non-negative fields of type duration or integers, IPs, label selectors. We have immutable fields, how to validate field is immutable. Our resource quantity is also used frequently, how to validate, which function to use for validating resource quantity, and so on. We have also field level validation errors. The important thing here is to use the appropriate field level error, just to pay attention to the semantic. For example, when a required value is not supplied, use field required. Yeah, at the end we have general guidelines, the conventions that are followed in the code base. Here we also reference the Kubernetes validation conventions. The interesting thing here is that 1 week ago, for example, they added a lot of new sections. All the sections that you see here, they were recently added. Previously, there were only guidelines for the error messages, and they were generic. For example, use must instead of may or should. But now, yeah, there are a little bit more specific guidelines. Okay, that was all for the Garner guide. Let me briefly mention also the extensions guide. This guide is for extension developers. The important things here are that extensions should leverage admission components, and these admission components should validate the provider configuration of the extension, because it's not validated, it cannot be validated by Garner. These provider configuration fields are of type runtime row extension. This is one of the important things, and the other is validation of reference resources. You know that extensions can reference secrets or config maps from the project namespace, and extensions should also validate them. Yeah, here we also have a proposal how to change this API to improve the framework that Garner offers for extensions. Yeah, in general, there are several open points that we want to improve from the guide. And yeah, one of them is this validation of reference resources. Next, we also have a few general guidelines. The important things here are that extension admission components should decode provider configuration to the internal type, and they should use strict decoding when decoding the provider configuration. This is done to prevent duplicate fields or unknown fields which are not supported by the extension APIs. Okay, I think that was a really fast summary of the guides. Again, I don't pretend to have covered everything and the guides to be complete and conclusive. If something is unclear or we have new warnings along the way, we should adapt the guides accordingly. Yeah, you can feel free to reach out to me so that we could improve the things, or you could directly raise pull requests. I want to also mention that it was a slow process to contribute these guides, because there were inconsistent things, and during the process I was writing down everything. And with Georgi, I want to also briefly mention it for several improvements that we made with Georgi along the way. So our improvements were in the area of the admission plugins. I'm not sure if I opened all of them. But yeah, here we first documented the types of all the admission plugins that we have, whether they are mutating or validating. We also moved a code which was belonging to the storage layer with this PR. We moved it from admission plugin to the storage layer. Then we adopted the type of admission plugin. It was its type was mutating, but it was not doing any mutation. So we changed it to be a validating admission plugin. The names of some admission plugins are still inconsistent. They are called validators, but they are doing mutations, or they are doing both validation and mutation. We tackled one such occurrence. We also have admission plugins that we should consider merging into Gartner API server. Maybe one of such admission plugin is the should VPA enabled by default. We now enabled it by default, and we are exploring ways how if we can merge the logic into the Gartner API server. Last but not least, we documented all the admission plugins there were some admission plugins for which we didn't have documentation on our side. These were mainly admission plugins coming from the upstream API server module. So they are also properly documented now, and it's clear for operator that they can be enabled for the Gartner API server itself. Okay, in short, this is all from my side. There are still many things to tackle in the validation area. We now have to follow up on the added guideline, and we have to fix the unclear points or the follow-ups from there. We also have some missing parts which are not validated. Some resources or some reference resources are not really validated. And yeah, there are still many things and many PRs to come in the validation area. That's all from my side.
Yeah, thanks, Ismail. Any feedback? Nope. Then over to Vladimir for the final topic today, the dedicated groups.
Okay. Well, so I want to present two changes that we recently made in Gartner. First one is this one, where we granted a few more permissions in the shoot cluster. So now we have some additional cluster roles and especially cluster role bindings where we bound to these new groups. So we have system and project level groups for all the admins and viewers, and a quick demo with a bit older version of Gartner, actually 1.126. So I have a shoot cluster already created here. It is reconciled with this version. And if I get, I have two users here created locally. One is project admin and the other one is Gartner installation admin. So if I create admin kube config for the shoot cluster with the project admin user, and if I ask who am I with this kube config, I'm actually part of the group system masters. And if I create a viewer kube config with the same user and also ask who am I, I'm also Gartner Cloud System viewers. So there is not much of a difference. If I do the same with the Gartner level admin, I should get the same groups. So I'm again system master and Gartner Cloud system viewer. Who am I? Yeah, I'm with this change. So what is? Well, let me just quickly just check out the latest version, the other change, and start up Gardener in the background until while I describe what we are doing. So with the next change, we actually want to change these groups, so we can distinguish when the kubeconfig is requested by a project admin or viewer, or it is requested by a Gardener level system admin or viewer. So we are changing the groups that are assigned to the admin kubeconfig and viewer kubeconfig depending on who is requesting them, and how do we distinguish whether user requesting the resource, what kind of role he has. If the user has the permissions to read all of the projects in the Gardener, then he's considered a system level viewer. If he doesn't have these permissions, he's considered the project level viewer. And for the admin kubeconfig, secrets are used for this check. So if I, for example, here with the project admin, if I try to get my project, I can read my project, but if I try to get all of the projects, I cannot get them because I don't have the permissions. With the system admin, I can read all of the projects in the system. And let me just quickly check. Okay, a few more seconds to. Okay, so now the Gardener API server is rolled out. And if I again request the admin kubeconfig with the system level admin and task who am I still should, now I'm no longer system masters, I'm now Gardener Cloud system admin. And if I get the viewer kubeconfig, I should be the same group, Gardener Cloud system viewers, before. But if I go and switch to the project admin user and try to get the admin kubeconfig and ask who am I, this time I'm no longer system admin, but I'm just project admin. And similar for the viewer kubeconfig. If I ask who am I, I'm now project viewer, not a system viewer. So now in the walks, being them access walks or audit walks or whatever, these users are easier identified where they are. Why do they have these permissions, where they are project viewers or so on. In terms of permissions in the shoot clusters, they have the same. Currently, they have the same permissions. There is no difference in this regard. So the viewers have the viewer permissions to see all of the resources except secrets and those that are encrypted, and admins have the full permissions they have the cluster admin cluster role assigned to them. So I think this is it from my side. Any questions? I can maybe quickly show the. Come on. Here we have the cluster role bindings in the shoot cluster, and here are the Gardener Cloud project admin and viewers, and the system admin and viewers. Cluster role bindings that are granting these permissions to these users. Yeah.
All right. Thanks, Vladimir. No questions. Then that's it for today. That was the final topic. Thanks everybody for joining. Thanks to all presenters, and see you again in 2 weeks. Have a good time. Bye-bye.
Thanks.
Bye.
Bye.
Bye. Thank you.
Bye.
Bye.